Welcome to Lesson 7.2, Solving Linear Systems by Substitution. So in Lesson 7.1, we looked at how we can find the solution to a linear system by using graphing. Now we are going to look at an algebraic approach known as substitution. So first, we're going to look at our 5 steps, and then we'll go through some examples. So the substitution steps, and this is when we have 2 or more equations. So in this case, we're just looking at 2 equations in our system for this lesson. So the first thing you want to do is in one of the equations, you want to get a variable alone. So you want to get y alone or x alone. Then you substitute the expression for that variable in the other equation. So for example, down here in A, once we knew that y was equal to the expression x minus 1, I can take this x minus 1 and replace y in the other equation. So you substitute the expression that the variable is equal to into the other equation, and then you solve that equation to get your first part of the answer, whether it's x or y. Then you take that first answer and substitute it into the other equation that you didn't just solve. Once you do that, you solve and you get your second answer, and then you write your answer as an ordered pair, x comma y. So these 5 steps are the same for all system of equations substitutions. So let's look through these 5 steps, make a little sense of what they mean. So the first thing we want to do, looking at example A here, we want to realize that we have 2 equations, y equals x minus 1 and x minus 5y equals a negative 15. So step 1 is already done for us. Y is already alone, so I know y is equal to x minus 1. So they are the same thing. Y and x minus 1 come out to be the same, so x minus 1 can replace y in the other equation. So for step 2, we're looking at this equation, x minus 5y equals negative 15, and we're going to replace the y with x minus 1, and then we're going to solve for x for step 3. So that equation would become x minus 5 times the quantity x minus 1. Because y has now become x minus 1, and that is equal to negative 15. So we have to use distributive property with the negative 5 here. Negative 5 times x is a minus 5x. Negative 5 times negative 1 is a positive 5. So we have x minus 5x plus 5 equals negative 15. Then we want to solve for x. So x minus 5x can be simplified to a negative 4x plus 5 equals negative 15. To undo the addition of 5, subtract 5 from each side. So we have negative 4x equals negative 20. And then to get x alone, we would want to divide by a negative 4 on both sides. So x equals 5. So now, step 3 gave us one of our answers, x equals 5. So we want to take that info, and for step 4, substitute that in to the other equation that we didn't use. So we're going to take the x minus 5 and put it into the first equation. So that first equation was y equals x minus 1. Well, now that we know x equals 5, we replace the x with the 5. So y equals 5 minus 1, meaning y equals 4. So for our final step, we're taking x and y and writing them as an ordered pair. Always goes x comma y. So our answer to this system of equations would be the ordered pair 5, 4. So let's look at B. So again in B, for step 1, we want to make sure the variable is alone. So looking at my two equations, 2x plus 2y equals 3, and x equals 4 minus 1, or 4y minus 1. So step 1 again is done for us. One of the variables is already on its own. X equals 4y minus 1. So for step 2, I'm going to take this 4y minus 1 and replace or substitute it for x in the other equation. So that equation would become 2 times 4y minus 1, so that takes the place of x, plus 2y equals 3. Distribute, so 2 times 4y is 8y, 2 times the negative 1 is minus 2. So we have 8y minus 2 plus 2y equals 3. Combine our like terms, 8y plus 2y is 10y. So 10y minus 2 equals 3. Add the 2 to each side, and 10y would equal 5. Divide both sides by 10, and y equals 1/2. So step 3, we got y equals 1/2. So then in step 4, I'm going to use that info, y equals 1/2, in the second equation that we didn't use yet. So we already used our bottom equation. So we already used our top equation. So we need to use the bottom equation. So we're going to substitute 1/2 in for y. So x equals 4 times 1/2 minus 1. So x equals 2 minus 1, which means x equals 1. So now writing our answer as an ordered pair, x comma y, x always has to come first. So our answer would be 1, 1/2. In C, again, step 1 was done for us. One of the equations is already solved for a single variable. So we know x equals negative 3y minus 1. So I'm going to take the negative 3y minus 1 and substitute it in for x in that bottom equation. So that bottom equation would become 2 times negative 3y minus 1 in parentheses, then minus the 5y equals negative 13. Distribute the 2 times negative 3y minus 1, giving us negative 6y minus 2, and then minus 5y equals negative 13. Combine like terms, negative 6y minus 5y is a negative 11y minus 2 equals negative 13. Add 2 to each side, divide by the negative 11, and y equals 1. So now that we know y equals 1, we move into step 4, and we're going to substitute the 1 in for y in the other equation, which would be, in this case, the top equation. So x equals negative 3 times y minus 1. Substitute the 1 in for y. So negative 3 times 1 minus 1, x equals a negative 3 minus 1, meaning x equals a negative 4. So our solution would be negative 4, 1. Then our last example on this first page, again, we already see one of the equations is solved for a single variable. So y equals negative 5x plus 3. So I'm going to take that expression, negative 5x plus 3, and substitute it in for y in the other equation. So that top equation would become 3x plus 2 times, in parentheses, negative 5x plus 3 equals a negative 8. Distribute the 2, so we end up with 3x minus 10x plus 6 equals negative 8. 3x minus 10x can be combined for negative 7x. So negative 7x plus 6 equals negative 8. Subtract our 6 from each side, divide by the negative 7, and x equals 2. So now that I have x equals 2, I'm going to take that and substitute the 2 for x in our bottom equation that we haven't yet solved. So that would become y equals negative 5x plus 3. So replacing the x with 2. So y equals negative 5 times 2 plus 3, or negative 10 plus 3, meaning y is a negative 7. So our ordered pair for D would be 2, negative 7. So instead of graphing these to find our ordered pair where the graphs cross, we're using substitution and solving both equations to get our 2 values. So now on the back page, we're going to look at 3 examples. I know there's 6 there, but we're just going to go through 3 of what happens if step 1's not already done for us. So how do we know which equation to choose to solve for a variable? Well, the answer is it doesn't matter. What I do is I look at my 2 equations and just think which one would be the easiest to get a variable alone. So in this case, for part A, we have negative x plus y equals 1, or 2x plus y equals negative 2. I decided to get the top one to have y alone because all I need to do to get y alone is add x to each side. So y would equal x plus 1. So I can get rid of that top equation and think of it as y equals x plus 1. So now I know y is x plus 1, so I'll substitute x plus 1 into this other equation for y. So for steps 2 and 3, substitute in for y. So we have 2x plus x plus 1 equals negative 2. So that can be simplified to 3x plus 1 equals negative 2. Subtract the 1 from each side, divide by 3, and x equals a negative 1. Now that I know x is negative 1, I'm going to substitute that in to the other equation. So this equation of negative x plus y equals 1. So putting the negative 1 in for the opposite of x, that would turn it into a positive 1. So 1 plus y equals 1. Subtract 1 from each side, and y equals 0. So our ordered pair answer would be negative 1, 0. So if we look at D here, we have a negative 3x plus y equals negative 18, and x minus y equals 14. Doesn't matter which one I get the variable alone on, but I need to get a variable alone on one of the 2 equations. So I use the bottom one here, and I decided to get x alone by adding y to each side. So that would mean x equals 14 plus y. So I'm going to think of this bottom equation now as x equals 14 plus y. Take the 14 plus y and replace x in that first equation. So we'd have negative 3 times 14 plus y in parentheses, plus y equals negative 18. Distribute the negative 3, so we have negative 42 minus 3y plus y equals negative 18. Combine like terms on the left, so negative 42 minus 2y equals negative 18. Add the 42 to each side of the equals. Then divide by a negative 2, and we end up with y equals a negative 12. Now I'm going to take that information, y equals negative 12, and use the negative 12 to substitute for y in our other equation. So our equation was the x equals 14 plus y, so we're putting the negative 12 in for y. 14 plus a negative 12 means x equals 2. So our ordered pair answer, remember always x then y, would be 2, negative 12. And then our last example for today, E here, we need to get one of our 2 equations to solve for the variable. So I'm going to use the bottom equation and subtract the 6y from each side to solve for x. So it would become x equals negative 6y minus 2. Oop, correction there. Should be a plus 2, which is going to change that answer quite a bit. So in this case, this would end up being a plus 2 here, not a minus 2. That would explain why my answer came out to be one really big funky decimal. So for your notes, don't worry about actually solving that one. My mistake on that, and if I'd go through, that would change this answer, change that value, change it all the way through my answer. But if you want to work through this one, we'll do it right now over here on the side. So instead of negative 6y minus 2, it'd be a negative 6y plus 2. So I'm going to substitute the negative 6y plus 2 into this first equation. So that would become a negative 30y plus the 10, not a minus 10, and then plus the 3y equals 1. So if you were going to work through this to get your solution, this would be the piece that we need to solve. So in this case, we would end up with a negative 27y still, but instead of adding 10 to each side, we'd have to subtract it, and that would equal a negative 9. So then in that case, we would want to divide both sides by the negative 27, divide this side by a negative 27, and we would end up with y equals 1/3. That looks like an x, but it should be a y. So y equals 1/3. So now that we have y equals 1/3, we would plug that in here for y. So this would be x minus negative 6, and instead of this part, so we'd get rid of this answer, instead of that, it would be a negative 6 multiplied by the 1/3 minus 2. So what I need to do there is take my y equals 1/3 and plug it in here. So a negative 6 times 1/3 minus 2. So a negative 6 times 1/3 is a negative 2. And a negative 2 minus 2 would be a negative 4. So x in this case would equal a negative 4. So our answer should be negative 4, 1/3. So as you can see, terrible parenthesis there. But as you can see from my mistake, so that should be a parenthesis, and that should be a negative 4. Real sloppy. So negative 4, 1/3. So as you can see from my mistake, if you make a mistake in that distributive property piece, it can impact your whole answer going forward. So right here, that should have been a plus 10 instead of a minus 10, which changed my answer here. Instead of a negative 11/27, that should be 1/3. And on this one then, instead of 12/27, that should be a negative 4. So our final answer again would be a negative 4, 1/3. Apologies on that one. So as you go through the practice problems, what you want to make sure, obviously, is that you are following these 5 steps for each problem. And make sure in step 1 that you begin with one of the 2 equations being solved for a single variable.